So when I was growing up, I always wondered why some materials dissolve easily in water and some materials don't, especially things like salts. Why do some salts, like sodium chloride, really quickly dissolve in water, and other salts, some lead salts, don't? And so I didn't really understand why that was until I took chemistry in high school and learned about these things called the solubility rules. Now, why are the solubility rules important? Well, when we do a double replacement reaction, in order for the reaction to be considered a reaction, we need to make new material. And when we do a double replacement reaction, most of the time the two reactants are pre-dissolved in water. So they're in ionic form or ion form in the water. And if they don't react, when you evaporate the water, you just get a mixture of the two salts back. But if they do react, you're going to make a new material. And that new material will manifest itself by precipitating out of the solution. In other words, it becomes insoluble. So understanding which materials are insoluble versus soluble will allow us to make predictions on whether or not a double replacement reaction actually works. So that is one of the reasons why we do this. And also, if we are going to try to dissolve something in water, we want to make sure that we have a reasonable chance of getting it to dissolve. So if you dissolve it in water, it means that it's fairly soluble. If it's not soluble, then no matter what you really try to do to it, you're not going to get a lot of it to solvate in water. So here are some examples. For example, silver nitrate, which is used in the photographic industry, is very soluble in water, whereas silver chloride is not. So those are two silver ionic materials, two silver salts. One is very soluble and one is not. Sodium carbonate, Na2CO3, is soluble, but lead carbonate is not. So now we've changed the metal ion and got one material to be very soluble and one material to be not soluble. Copper 2 sulfate is soluble, but copper 2 hydroxide is not. So again, we're changing the anion, and that's changing the solubility. And again, and last one is copper 2 sulfate is soluble, but calcium sulfate is not. Again, because of the situation of the solubility rules, we now have an understanding and can make some predictions on whether or not a material will be soluble in water. Okay, so as with anything in chemistry, there's generally a guideline or a set of rules. Now, there are 6 of these rules, and they look pretty complicated, and they're applied in the order that they are listed. So, for example, order 1 here, the first rule we look at is the alkali metal. If we have an alkali metal, then they're always going to be soluble, no matter what the anion is. So if we don't have an alkali metal, then we go to number 2. All acetate, perchlorates, chlorates, and nitrate compounds are soluble. So if we have any of these anions here, no matter what they're bonded to as far as a cation, they're going to be soluble. Then we have this list here. Silver, lead, and mercury 1 compounds are insoluble. So silver compounds are insoluble. Remember, so I said before that silver nitrate was soluble because the nitrate compounds are all soluble. It doesn't matter that it's bonded to silver. This rule applies before this rule, before this rule, before this rule. So this is the king, the queen, stuff like that. So if it doesn't fit this rule and it doesn't fit this rule, then this rule is next. If it doesn't fit that rule, then that rule is next. So whatever rule it fits, that's the one we're on, okay? So again, the rules are applied in order. Well, this is pretty complicated to memorize all this stuff. So how can we do this in a simpler way? Well, we have a chart that has all of these rules in it in a nice tabular form. And here is that chart. So let me explain how this chart works. This chart is set up to have mostly anions. the negative ion on here. Now, there are a few exceptions right here. Those are my cations, but everything else looks like it's an anion, right? Now, this side of the chart are all the ions that are soluble. This side of the chart, all the ions that are insoluble. Now, there are always exceptions to the rule. So let's, for example, look at halides. So the halides say that halide is just another word for halogen. So the chlorine ion, the bromine ion, and the iodine ion are all soluble except when they're bonded to silver, lead, and mercury. Now, if you remember, go back to the rules, the silver, lead, and mercury rule was above this rule. Okay, now you don't know that because you didn't really look at the chart, but I'm telling you that this rule is like rule number 4 or 5, and this rule is number 3. So 3 trumps 4. So yes, they all are soluble. Everybody's soluble except when they're bonded to this. Same thing with the sulfates. Everything's soluble except when they're bonded to these. So if it's just this and there's no exception, then everything that has this acetate, this nitrate, this ammonium is always going to be soluble. On this side of the chart, everything that's bonded to carbonate is insoluble except when it's bonded to these things. Here's the group 1 thing again. That was the number 1 rule. Chromate, again, number 1 rule here, and ammonium. Phosphate, number 1 rule again. So the exception to the rule is if it's bonded to phosphate, you look for the exception. If this exception does not meet what is in the compound, then the phosphate is insoluble. Same thing with the sulfide, the hydroxide. Okay, now we're just talking about insolubility in water. There's a whole different solubility chart if you're dissolving it in, say, alcohol or some type of hydrocarbon, all right? So we just care about water. So let's show you how this chart works on the next page. Okay, so here's my chart again, and here are the steps that we're going to use. And we're going to walk through these steps, and then I'm going to show you an example on the next page. You only use this chart for a double reaction. You don't use it for anything else unless you're looking to see if you want to take a salt and try to dissolve it in water, right? And then you can use this chart. But other than that, you're just going to use it for double replacement reactions. So you first have to determine your products. Remember that for the double reaction, you're going to switch partners, to switch the anions. And then separate your products into their constituent ions. We'll show you how to do that in a second. Look for your product's anion on the chart. The anion is the one that's listed on the chart, except for a couple of them. So the anion is going to be listed. We're going to look for that first. If you can't find it, then you go to the cation. Determine if your ion is generally soluble or insoluble in water. So which side does it fall on? Does it fall on the soluble side or does it fall on the insoluble side? Look at any exceptions. If the other ion listed is an exception, then the solubility is opposite of the general class. Remember, here's the general class of soluble. This is the general class of insoluble. So let's see how it works on the next page. Okay, so here's how we do this. So what I always do, and this is the way I was taught, and this is the way I'm going to teach you, is, again, we always want to separate our compound into the cation and the anion. So these are ionic compounds. So we're going to find the first cation, which is the NH4, that's the cation, and so we're going to draw a line right between these two, right? And then the same thing over here, CaSO4, we're looking for the second capital letter, and there it is. So this is my cation, and this is my anion, and this is my cation, this is my anion, okay? So now we're going to circle the anion, PO4 and SO4. Those are my 2 anions. So we're going to try to find those on the chart. So let's look for PO4 first. So we're going to go down here, and we don't see it on the ions that are generally soluble. So that's on that, not on that side. And then we keep down here. Oh, there it is. So here's my PO4. Okay, so now we know that PO4 compounds are generally insoluble. Now, are there any exceptions? There are. And the exception is when combined with group 1 ions, NH4 is not a group 1 ion, or the ammonium ion, which is NH4 plus, and there's my NH4 plus. So the exception to the rule is it's generally insoluble except when it's bonded to NH4 or a group 1 ion. So in this case, this material is going to be soluble. Probably spelled that wrong, but soluble. Okay? So again, here's what we charted, that we listed it generically insoluble, but not when bonded to NH4. So the NH4,3 PO4, the ammonium phosphate, is soluble. Now let's go to the other one real quick. And again, we're going to look for our SO4. So we're going to go down here and and we find sulfates right here, SO4, and that's generally soluble. So generally it's soluble, so it should be soluble in water, except when it's bonded to silver, calcium 2 plus, strontium, and there's my calcium 2 plus right there. So it normally would be soluble, but since it's bonded to calcium here as the cation, it's now insoluble. So this one, the calcium sulfate, is going to be insoluble. And that's pretty much it, how the chart works, right? So again, here's how we read the chart for that one. We read the chart saying we found the SO4 sulfate, and it's generally listed as soluble. We said that, but not when it's bonded to Ca2 plus. What's the exception to the rule? So since this is the exception, generally soluble, the exception means it's not. So CaSO4 or calcium sulfate is insoluble. Okay, so I'm going to show you one more real quick or two more real quick, and then I'm going to have you stop the video and try the rest of the 4 on your own, all right, and then work on that worksheet that I'm giving you. So let's, again, here's how I set it up and here's how I do it. I'm going to go find my compound, aluminum carbonate. So we're going to find the separation between the carbonate and the aluminum, and that's my cation here, the aluminum, that's the metal, and here's my anion, the anion, the negative ion. And so let's circle the carbonate, because that's what we're going to look for, CO3. And we're going to find CO3. We go down on this side. It's not one of the more soluble ones. And here it is. It's listed as a insoluble. But there are exceptions to the rule. So we know that aluminum is a group 13 metal. So it's not a group 1 or a group 2. And so we're looking for when combined with a group 1 ion, which aluminum is not, or ammonium, which aluminum is not. And therefore, none of these exceptions work. So these are out. And so therefore, it's insoluble. So this would be insoluble. So INS, insoluble. Now let's look at let's look at ammonium sulfide. Let's look at this one right here, ammonium sulfide. And we're going to then, again, look for the separation between the two cation and the anion. So let's do that, and that's right here. So we're going to be looking for the S of the S2 minus ion. So let's find that up here. And we go down the chart again, and we don't see it. And then so we're down on the insoluble chart. Oh, and there it is, sulfide. So it's generally going to be insoluble, except when combined with group 1 ions, and NH4 is not a group 1 ion, or the ammonium ion, NH4 plus, and there it is. So even though that the sulfide ion is most of the time insoluble, this time it's soluble. Okay, so you're going to do the other 4 here. So you're going to stop the video when I tell you to. silver bromide, barium chloride, magnesium chromate, and sodium chloride, and tell me for each one of these whether or not they're soluble in water or insoluble in water. And using this chart, remember again, separate the cation from the anion, look for your anion, the negative ion, on the chart here. When you find it, make sure if there's an exception, it doesn't pertain to the cation that's bonded to it. And if it does, it's going to be opposite of whatever category it's in. So this is the soluble ones. These are generally the insoluble ones. Okay, so get ready to stop the video. Stop the video now. All right, so here are the answers to the problems, right? So sodium chloride, everybody knows that's pretty soluble in water. And barium chloride is soluble in water, but silver bromide is not. Aluminum carbonate is not. Magnesium chromate is, and again, as we said before, that ammonium sulfide is soluble. So now you're going to do the worksheet that I gave you, and then work on that, and I will provide the answer key later on in the day. Use the chart that is provided with the worksheet. It's the same chart that's in this little tutorial video.